This time I got a Crown DC300 160 watt per channel power amplifier. This one's got some major DC voltage on the speaker terminals, and apparently the speakers that were connected to it when it failed went up in smoke. Not a good design. No speaker protection at all in these monsters. So when something goes bad, it really goes bad. Let's check this one out and see what's wrong with it. This is an Amcron DC300. I'm told it doesn't work. I'm told it blows up speakers. We're going to do an inspection on this one today and see why it's blowing up speakers and see what the fault is. I don't know that it's going to get repaired in this video or not, because I don't have any service information whatsoever on this unit. And I've already gone and searched on the standard sites, and I can't find any information whatsoever on this unit. It's a Crown. (1200 watts input power. It can operate in stereo or mono, and this is a big bugger. So first things first, let's check this out and see if there's any DC voltage coming out the speakers. I'm gonna have to resurface my bench after working on this thing. A unit like this, I'm going to power it up using my dim bulb. That'll charge these caps up slowly and not blow the fuse on my Variac and not blow my main breaker, which some of these big amps will do. They'll trip the breaker. So if I turn on the power, this will allow the capacitors to charge up. It's like a soft start. And we're just going to take the meter and in DC voltage mode just measure if there's any DC voltage on the speakers. We have 57 volts on this channel. That's bad. That would explain why the speakers went kaboom. This side has also 57 volts. So the fact that we've got 57 volts on both channels, right, is a good indication that maybe the negative supply is bad. So let's open this up and see if there's something that's causing the negative supply to be missing. Because what will happen, just like with that Pioneer, where we had a loss of the positive supply, everything went negative. So the same thing happens. It's a balanced output. You've got a positive rail and a negative rail, and if you lose one of them, the other rail, everything will go that direction. So let's pop the top off this one first. We'll put some lights on so I can see what I'm doing. Turn on all the studio lights. You guys can probably see it changing a little bit on camera. We'll just start popping the top covers off and take a peek inside and see if we can figure out what's going on. It'd be really nice if I had a schematic for this, but I don't. I went to my normal source, Hi-Fi Engine, and as I say, they've only got one model of Amcron listed, and it's not this one. And it's not even a full schematic either, so. Mounted to the top cover is a bridge rectifier. I see there's a fuse that at one point used to be attached to the top cover using double-sided tape that's fallen off. I wonder if that fuse is popped. Let's pop it out and see whether this fuse is popped. Nope, that fuse is okay. So it's not something as simple as a blown fuse, although this fuse should not be just hanging in free space waiting to short out against something. Looks like this is just an AC fuse. It's in line with the other fuse. They went and put a second fuse in series. That's because they know what people do when fuses blow. They put too big a one, and so what they've done here is it's just a second fuse going right to the AC line, and then it goes from here to the other fuse holder. So that's all that is. It's just a secondary fuse that someone has installed after the fact, probably because some dummy that owned this thing put too big a fuse in when it blew, and it blew the crap out of it. So when a tech was servicing it, he figured, okay, I'll fix this, I'll put a second fuse in, and he just stuck it to the inside of the cabinet here, and it's fallen down. But that's not our problem. That's just one of the problems. I was able to find a print for it. Instead of looking it up under Amcron, I looked it up under a Crown 300, because an Amcron is a Crown. Amcron stood for American Crown. And on Hi-Fi Engine, they have both. They have both Amcron and Crown listed, and under the Amcron, which is what this one clearly is labeled, they had no DC300A listed, but they did under Crown. So here is the schematic. If we look at the power supply here, we'll see that the power supply goes through this giant bridge rectifier, and that gives us our plus 60 volt and negative 60 volt supplies. So first thing to do is to check to see if we've got a negative 60 volt supply coming off the power supply. We can measure reference to ground, power on. We have our, try putting it in DC mode, might help. We have our 58 volts on this side, and we have negative 58 on this side. So power supply is outputting both voltages. Okay, the fact that the problem is affecting both the left and the right channel, I don't think we're going to have a problem with the outputs. The output transistors are going to be fine because it's affecting both channels. If it was just one channel that was DCing, then yes, we could have a problem on that board. The fact that it's both channels takes me back to the preamp, which is on the front panel. So I got to pull the front panel off, and we'll check some voltages there. I'm convinced that we've just lost one of our voltages, and that is why it's not working. So I got to disassemble this front panel and remove it so that I can actually get to the circuit boards behind here. A couple screws out from the side, two on the top and two on the bottom, and the front panel should pull off on this one. There we go. It's already coming loose. Alright, now I can remove the front panel to access the preamp board down here. This is where I think the problem is going to be on this one. Alright, this unit's got a socketed IC. Let's make sure it's plugged in. You know how I feel about socketed parts. Let's check first of all, put on the power. I'm just going to just check to make sure that I've got both my positive and negative supplies getting to the actual output board on this unit. Let's just check and make sure we have both our positive and our negative supply. There's our negative supply, minus 58. And there's our positive supply, 58 volts. So we do have both our positive and our negative supplies getting to the board. Let's just check our inputs from the preamp stage. Minus 58. 58, I'm just looking to see whether there's any. 57, that should be minus, that's got 57 on it too. Oh. I kind of think that this one should be a negative supply. And this is a positive supply over here. You see, because we have a negative here. I think this one probably should be a negative supply coming off of this board here. 58 volts. 58 volts. Where's our negative? See, we've lost our negative. There's our problem. There's no negative supply feeding into the drivers on this board. So we have one PNP and one NPN transistor. So where is our supply feeding into this board? This one's got 0. $57 volts. 57 volts. Don't mind me, I'm thinking out loud. Shut off the power here for a minute. I'm just going to consult the diagram and see where our negative supply is fed in here. I hate these stupid schematics that are just ridiculous to read. They're just not very good prints. And 739, is that what the number of this is? I think this is the schematic. I've got two different prints, right? Two slightly different schematics. See, they changed. They did a production run change, so they've got two different versions of the same amplifier. See, it says here, this is a representative schematic only and does not necessarily reflect the exact circuitry of your unit. It's probably going to be a resistor that's open, or something along the lines like that, that's causing loss of the supply. Oh, what the? That's kind of, check this out. Check this out. I just noticed this. Does that not look like a big solder splash that's sitting on that switch from the prior service? It sure does to me. Like, what the hell is that doing in there? Well, let's just turn this thing on again. Did our voltage disappear, or is it still there? I'm sure it's still there, but maybe that's what caused the problem. It was a short circuit on that switch. You see how the switch works. If you look here, dual and single, mono. So when it's in mono, the black and the silver wires are bridged together. These two. Because it's on that way. When it's in stereo, the black wire is grounded. So it's in stereo mode. The black wire is grounded. There's a bridge sitting there, which is now shorting this other wire to ground. I wonder if that's what blew this up. That goes into this IC here. This is probably an output from one channel to feed. Yeah, you know what? It's feeding the output from. It's feeding the inverted output into the negative input from the other amplifier, so that you get an inverted phase. Right, it's going into the IC here. So what it's doing is, when it's in the mono mode, it's taking an output, it's taking the inverted output and it's feeding it in, or taking the output and feeding it into the negative on this one. But this line here, it comes down like this. This comes straight down here, and it goes, this wire here, you can see that I'm moving it. It comes right down here and it goes into this IC. It even could be the IC is cooked. But let's hope that's not what it is. Let's hope it's just a resistor that's feeding in. The negative supply is bad. So let's see where the negative supply comes in. Alright, wrong schematic. It actually is this one. It's got the mono switch down here. I just missed it initially. This has only got one IC in it. The other one's actually got a couple different ICs. When I took a closer look at it, it's actually got two ICs. Actually, it's got three. IC1, A, B, C, D, and then IC100 and IC200. So this one's got three ICs in the circuit to drive it. And so we can clearly see this one's only got one. This is the correct print. There's our stereo mono switch. Same thing though, except for in this case now, when it's in stereo mode, it's going right into the IC. there's a good chance that's where our failure is in the IC. I'm just going to see whether there's any negative voltages actually getting to this board. So I'm just kind of studying it to see where the power comes in. Actually, there is. I can see here. This is a really tough print to read. But the negative voltage does come in here somewhere. That's the positive voltage there, it looks like. Where is it coming in? Okay, it comes in here. Negative supply comes in. It feeds all the outputs. If we look at the negative supply, there's a negative supply is coming in. It comes in from both power modules, right? Because it's a single power supply, so it's fed in this way. This feeds all the negative transistors. We know that that part's good there, and then it feeds over. But you see, both of them feed together. They both come up here and they go into this one little resistor here, and it's a 3.2 ohm. Looks like 3.2 ohm, 1 watt, and then feeds into this output offset. So let's just look. There's got to be a resistor on this board that's open, I'm thinking, for where the negative feeds in from. So the board over here. So if we follow the negative input, it comes in through this resistor here, and then connects across to here, and there's a Zener diode here that clamps the operating voltage for the negative input to the IC. Let's find the Zener diodes. Hold on just a second. As I say, this is why when you're inspecting, a visual inspection is really worthwhile. That resistor is not connected to anything. It's broken. Let's see where it's broken from. Alright, there's a resistor here that's broken. Where does this resistor go? Good chance it goes right to this ground. It looks like it's broken off right from there, doesn't it? It looks like that resistor went in there. I'm pretty sure that that's where that resistor went. Let's just attach that resistor. Okay, let's solder this wire, this resistor back on. Where I believe it goes. Yeah, that's where it went. That's where it came from, because as soon as I heated it up, the piece of the old wire that was in there from the resistor that broke off actually came out. So that's exactly where that wire goes. And we'll just turn this thing back over on its, where it belongs, on its base. Get all the components that could short out of the way. The cover plate and stuff out of the way. Okay. Do we have voltage on here? Ah, damn! We still have 56 volts. So that resistor, even though it was broken, is not the cause of our DC. I was hoping that it was, but no such luck. Back to the drawing board, or in this case, the schematic. Okay, let's check the voltage going into the IC. I went back and looked at the PDF where I could blow it up on the screen so I could see what was going on, because when you try to print big schematics on small pieces of paper like this, it leaves a lot to be desired. You miss a lot of stuff. Plus 10 volts supply onto pin number 2 of the IC, and the negative 10 supply should be pin number 7. So here's pin number 2. Turn on the power. Pin number 2 here has 10 volts. Pin 7 has 10 volts. Aha! We should have negative 10, but we don't. We only have positive 10. Therefore, if we look back on the schematic, we'll see that the negative 50 volt supply comes in. It goes through this resistor. Is that showing up, or am I blowing out the camera? It goes through this resistor here. It's a 33 ohm 1 watt resistor, which drops the voltage down, and it should be clamped to negative 10 by this Zener. Now the very fact that it's, when we check it here, because the Zener goes right into pin number 7, we've got positive voltage there, we should have negative. So the Zener itself's not flipped. We have no bias voltage getting in. We got to go back and find that resistor. It's either that resistor is open or one of the wires is broken. But since it feeds in from both boards itself, I think it's probably going to be the resistor. So we just got to find that. It's a 33 ohm 1 watt resistor. Shouldn't be that difficult to find because a 1 watt resistor is relatively big on a board like this. Just got to find it. Where the heck is it hiding? Like, it should be easy to spot. And yet, I don't see it. I'm going to pull this board just so I can see what's in behind here. I have a discrepancy between the schematic and the parts list. The schematic shows 33 ohm, but the schematic shows that this is R8, and it shows R3 and 8 as 2.7K, and R3 is on the positive side, and R8 is on the negative side. Yet on the actual drawing itself, it's clear as a bell. It says 33 ohms. Which sounds kind of low, you know, for dropping 50 volts down. I think it probably is supposed to be 2.2K. Because looking at the schematic itself, it just doesn't look right. But let's just see trace back where the connections go on the board here. We'll look for bad connections too while we're in here. Looks like somebody's been soldering away on here at some point. Look up. Look way up. Boys and girls, I think I found the problem. Take a close look right where I'm pointing with my finger. Do you see something that seems like it's missing? Let's see if we can get a better shot of that. Does that not to you look like there's a strip of foil that's blown off the board right there? And this just happens to be the line that goes right to that negative supply. And it looks like there's a strip of foil that's missing that used to go across right down here. Doesn't it? Well, let's just see whether there's voltage across that. I bet you we got negative supply on one side and positive supply on the other. Okay, meter on. Power on. Okay, here we've got, what do we got on here? Got nothing. Why do we have nothing? We got positive on one side. This should be negative voltage. It's 0. Interesting. But that looks like that's a trace that's open. And that goes right to, that trace that's open is what goes right to this pin on the IC. That's connected right to this balance control, which should be connected to this negative circuit. There should be voltage there, but there's not. But obviously that foil is open. Okay, if we move away the wires down here, looks like that's where the Zener diode that I suspected might be shorted, the negative 10 volt Zener. Looks like that's where that lives. This is going to be the resistor right here, and it's actually a 3.3K resistor. Wonder why the schematic said 33 ohms, but it says 33 ohms, but I'm sure it's supposed to be 33K. This resistor is okay, but there's a Zener diode right behind here. When I measured it, I should have had the negative voltage on there, and I had 0. Well, that would explain why, because when I put my meter on here, I have negative 50 volts on one side, and I have 0 on the other. I bet you this Zener is shorted. If I can get these wires out of the way so I can actually get my meter in there to measure it, I bet I'm going to find that this Zener diode is, in fact, shorted. Okay, so we got a shorted Zener, open trace. It's a 10 volt. Yeah, IC could be bad. The way that trace opened, maybe this IC shorted, but maybe not. Okay, let's find a new Zener diode and we'll repair that trace. I've got a 9.1 which is as close that I have, and I'm going to have to use that because, well, that's as close a value that I have for it. So let's get the old one removed and get a new one in place. I love these boards with all these wires in the way. Solder wick in there and remove it. We'll remove the plug just so that it doesn't accidentally get switched on while I'm working on this. Not that I would switch it on, but just in case the switch got bumped. Better safe than sorry, as they say. This is the old Zener that's out. As you can hear, it's shorted. Would make this not easy to get at. So I'll solder that one back down. We'll solder it on this side, and I'm just going to take this lead here and continue on and fix the trace that's broken using the remainder of the lead. Make sure it doesn't short out to anything else while I'm at it. There, that should correct the fault. I'm just going to get a close look and make sure there's nothing shorting out before I apply power. You see what I mean? 1, 2, 3, 4, 5, 6. Six messages in a row here. Google network operations. And this is what he says. Terminate account. Spam complaint. Terminate account. 20 recipients. These are all the people he's sending this out to. He's sending them out to support at admin, Susan Daniels, YouTube, abuse at YouTube, hostmaster YouTube, support YouTube, legal at YouTube, and then abuse at telus.com, and abuse at telus.net, and knock at YouTube, and to me. Here's some more. These are more. And for some reason, he's sending it out to Fran at frantone.com. I don't know why he's sending copies of it to her. Like, that's Fran Lab. Why is he sending copies to her? And whenever he makes a complaint about one of her videos, I get a copy of it too. The guy is just a psycho. The guy is just an absolute psycho. And then he sends out from his anti-hotmail. He's anti-hotmail. He sends out my address and phone number, well, what he thinks is my phone number. And then he has all these paste bins that on here that pretty much link to every video I've ever done. And he sends this out. I mean, it scrolls on forever. It scrolls on. There's hundreds. He's got a link to every video pretty much I've ever done. And he sends this all out every time. The guy is just absolute certifiable nut. Can you tell I have confidence that it's not going to have a big negative voltage on it now? That's why I'm putting some screws back in. Or big positive voltage. I don't know, maybe I'm a little overconfident. Maybe it's still got a problem, but I'm pretty sure that this is going to, unless this IC is cooked, the IC could still be foobar. But the IC could have been what blew up the Zener. I guess we'll find out if it blows the new one. If it's sending a positive voltage back on the negative rail, that could have cooked the Zener, right? But we'll find out. We'll find out fairly quick here if I've got any DC offset still. All right, I'll put my probe on the speaker terminal as I hit the power, and we have 56 volts again. I wonder if it cooked the new Zener. Well, let's see here. This is my negative supply. I got 0.7 on it. I bet you it hasn't cooked the Zener at this point, but I bet you it's heating it up. And I bet you this IC is bad. Let's just pull the IC and see whether the negative supply comes back. But it could be this IC is cooked. Okay, IC is out. Let's see if my negative supply comes back. Oh yeah, it already is. Okay, just turn it on and off for a second. There, we got 8 volts. So IC is cooked. Now we need to source this IC. It's shorted. It's supplying positive voltage through to the negative rail and pulling the system out of balance. Definitely this IC is shorted, because remember before when we tested it, before we had our plus 10 volt supply on pin 2, but we also had 10 volts on a pin 7, which is the negative supply. So now if we look at pin 2, which should be our positive 5 volt or 10 volt supply, we see that it's down to 1 volt, and the pin 7 is like at 0.7. So the IC is shorted, and it's actually pulling the positive rail down as well. If I unplug the IC, then my negative and positive supply voltages come back. So this is the resistor here. This is the negative resistor. If we look, we've got negative 51 volts there. On this side we're sitting at 0.6 right now, because the IC itself is pulling the voltage down. If I pop the IC out, then the voltage comes back here on this side, and also on the positive side we get our plus voltage back. So this IC itself is cooked. That might have been what blew the foil strip open on the board. It's something shorted and blew the IC and blew the strip. But anyway, now we know where we stand. I've got to find a UA739PC. I think that's the number of this one, UA739PC. I say good luck trying to find that, but we'll see if one's available. So here's our fault. So the IC here, it's a UA739PC. It's a dual op amp is all this is. And it takes our input signal and it amplifies it, and this is where we set our offset. So we're actually applying a DC voltage to balance the input, which provides a slight offset either one way or the other to compensate for and bias and balance the outputs, right? This is our balance control. output offset as it's called, to make sure that we don't have a DC voltage, because these big old amplifiers had nothing in the way of protection, and any imbalance would actually cause a DC voltage. I mean, I don't know why so many people are after old amplifiers like this, because as you can see, there is no relay, there's no speaker protection. Anything that goes wrong in one of these amplifiers will result in cooked speakers, and you would never catch me running my nice expensive speakers with one of these old brute amplifiers, just for that very reason, is that I value my speakers and I don't necessarily want to have to buy new drivers. Or worse, if the voice coil catches fire and sets fire to the cone, and that sets fire to the speaker, well, that could in turn set fire to your house. So you've heard the term unsafe at any speed. Well, this design of amplifier is one that I would call unsafe at any speed. They are, you know, they're monsters. They're got a lot of power. This one's 165 watts, I believe, per channel. So they got a lot of kick to them. And when they work great, but it doesn't take much to upset the cart, as they say. And all it takes is a Zener diode to short, for example, and you've lost one of your supply voltages, or in this case the IC pop. But why the IC pop? We don't know. Did it pop because there was a surge? Did it pop because the Zener didn't obviously go open because it shorted, unless it went open and it shorted. But I think more likely something happened that caused loss of drive, which caused that IC to pop, and that Zener failed. Probably the IC shorted, and although IC shorting shouldn't kill the Zener, unless, see, it's hard to say. Why did the Zener fail? The Zener was shorted. Zener shouldn't short, but it was. The Zener was shorted. You know, unless it got a kick from one of these other rails, which is a possibility. There's another transistor over here. One of these transistors, I guess, could have shorted, but then again, there's a resistor along here which should limit the amount of current that would get to it. Anyway, IC is cooked, so we got to find a new IC before we can go anywhere, because it's pulling down the positive rail. Now that the negatives returned to it, it's pulling the positive rail down, so we got a problem in that IC. So I guess we're going to call it a day on this one right now. I'm going to throw the front cover back on, and the top and bottom cover pieces on here, and we'll leave it at this for now, as this one I'm going to need to get parts. Got to get a hold of the guy that owns it first too, and see how much money he wants to spend on it and so forth. From what I understand, the guy that got this got it for a song. But we'll take it from there. Got to source the IC. It's going to be a tough one probably to find at this point in the game. There was a time when it was replaceable by an NTE part, but when I looked it up on the NTE cross directory, it says that the NTE replacement is no longer available, which means that there may be a problem getting the part for this one. Anyway, I'll throw it back together for now, and we'll pick this up again at a future date, should we go ahead to fix it. Thanks for watching. We'll catch you in the next one. Bye.